So relation between EMF of a cell and decrease in del G, that is decrease in the Gibbs free energy in a cell. A galvanic cell produces the electrical energy as a result of chemical reaction occurring in it. So when the cell current flows through the conducting wire, the connection with the anode and the cathode, electrical work done is done by the cell. For a reversible cell, the electrical work must be derived from the cell is found to be maximum. Let the EMF of a reversible cell EMF of a reversible cell that we are taking it, that is E cell. Number of moles of electrons in the cell reaction. So in the cell reaction, number of moles of electrons that we are taking it as N. So N electrons will be flowing through the wire and connecting the anode and the cathode. So EMF of the cell is an intensive property. You know about what is intensive and extensive property. Intensive property, so this can be explained from the relation that is del G gives free energy. It is N, F and E cell. This is the relation between Gibbs free energy. Now if we rearrange it, if I take E cell from here, from this reaction, del of G by NF,
Sir,
and it's negative here. Yes,
del G is negative.
Gibbs free energy always decreases in a cell reaction. So Gibbs free energy, it is equals to minus number of electrons, Faraday constant, and the EMF of the cell. So this is the change in Gibbs free energy. So what are you finding from here? So Gibbs free energy, NF, the amount of electrical charge is also, these are being NF and G. The ratio of these two properties, which is representing an intensive property. Say for example, in the cell reaction between the zinc and copper, it is forming the zinc ion and copper atom.
Yes.
So in the electromotive cell, here it is, E cell is XV. If the reaction is multiplied with by a number that is N, so it would be N into Zn, N into Cu, 2 plus, N into Zn2 plus, and N into, this is the number we are multiplying in the reaction.
Then, so why are we multiplying n?
So if n number of zinc ion, it is being oxidized to n number of zinc ion, then what would be what is the EMF of the cell? It is the same EMF of the cell would be still, that is xv. So though the here the number of amount, if I take more in the amount of the reactant and in the product it is forming, that is n number of also. So EMF of the cell, it remains the same. Now we are going to find the relation between the EMF and the free energy. So amount of electric charge carried by n mole of electron, it is equals to NF. As we know, one mole electron, the charge it carries, it is F. So for F, it is NF. Now, what is electrical work done? What is the amount of electrical work done? So here it is the quantity of charge into the potential difference. Is that fine?
Yes, sir.
So maximum work derived from a reversible change is W max. Maximum work we are taking out from the cell. It is equals to the quantity of electricity into EMF of the cell. So we can write what is the quantity of electricity here. The quantity of electricity is the NF. So NF into electromotive of the cell. So we can write this is NFE. NFE of the cell. Now work done is, what is the unit of work done? That is joule. So NFE joule. Now what is for a reversible cell? It decreases the free energy associated with the redox reaction. So free energy get decreased if we are taking the work done from it. Is that clear?
Yes, sir.
So in this kind of cell reaction, it is equals to the electrical work done by the cell. So we can write, well, the the free energy decrease in free energy, it is equals to amount of electrical work done that being taken out. So decrease in free energy, এটা কি decrease হলে minus দিয়ে represent করি, minus del G. If it be an increase in free energy, we will be saying positive del G. Fine. So del G is equals to NFE of the cell Now taking the negative in that side, so del G is equals to minus NFE of the cell. So this is the expression of Gibbs free energy. Increase in the Gibbs free energy. Now one thing here. Now if it is the standard electric EMF of the cell is given, then it gives me the standard decrease in the Gibbs free energy for the standard. Remember. So everyone got it?
Yes, sir.
Okay. Copied?
Yes, sir.
Oh, hold on. And here it is.
পুরো একবারে পুরো একবারে করে দাও।
Oh, Puroda. Fine.
হুম,
This remaining is
ভালো হবে।
yes.
হ্যাঁ,
Okay. Now, what is the importance of this reaction or significance?
Sir, of which reaction?
That is del G is equals to minus NFE of the cell. Importance of this. So, at constant pressure and temperature,
Sir, by this we check now whether the reaction is spontaneous or not.
is spontaneous or not?
Yes.
Yes, the significance we can say the spontaneous also, right? So, at constant pressure and temperature, Lg is negative for a spontaneous reaction. Mane, it is going on, right?
Yes.
And del G for a spontaneous reaction and at constant temperature and pressure. And del G is positive, মানে increase in the free energy. কখন হবে? In a
It
non-spontaneous
is not spontaneous. Sir,
and, and del G is equals to 0.
sir, the temperature and pressure is always constant.
Now at constant temperature and pressure and at spontaneous reaction, del G is negative. Means, say for example, we are using the battery or we are using the EMF, etc. We are not changing the temperature and pressure outside. Then it is a spontaneous reaction. In that case, the decrease in the Gibbs free energy. And del G equal to 0 at the equilibrium.
So when del G is equal to 0, then reaction will not take place.
Reaction মানে যতটা ফরওয়ার্ড রিয়াকশন হচ্ছে ততটাই ব্যাকওয়ার্ড রিয়াকশন হচ্ছে. So the Gibbs free energy is equals to 0, or we can say that we are not deriving any work from the cell, or we can say whenever we are not using the cell, we can say it is being constant and it is at equilibrium.
Yes.
Clear?
So means the equation or the reaction is totally balanced.
কোনটা লাস্টেরটা?
Yes, sir, at equilibrium.
At equilibrium, the forward reaction is equals to the backward. So it is at equilibrium, remember.
Means it is reversible.
Reversible. If non-reversible, so not.
Okay.
Now conductance of the electrolyte. এটা আমি scroll করলাম. Conductance. What is no? You know the conductance is opposite of resistance. So electrolyte in the molten or in the dissociate state in an aqueous solution conducts electricity. So in the molten or in the aqueous, it is conducting electricity. Now aqueous solution of the electrolytes are generally used in the various experiments in the electrochemistry. When the potential difference is applied between the two electrodes is dipped into the electrolyte solution, the ions in the solution move and conduct electric current through the solution. So,
Sir,
hmm,
but did you tell the ions move in conductors?
in the solution, in the electrolyte solution, the ions are being responsible for the conductance of electricity. Now, we will be discussing here obeying the Ohm's law.
Sir.
What is
In
Ohm's law? Yes,
sir,
tell me. Ah.
in that cell we were taking Zn and Cu2 plus. Was it conductance?
So yes, the zinc ions would be, it is dissolving in the in the zinc sulfate, or what is that solution?
Cu4. Cu2.
And copper sulfate, and here the copper ions are also mobile copper ions. So for this mobile ion, it is helping in the conductance. So what I discuss now here, that is conductance of a electrolytic solution in the molten and aqueous solution is due to the ions present in it. Right? And it obeys the Ohm's law. Now, what is Ohm's law? Can you tell me what is Ohm's law?
Is equal to IR. Means the potential difference is equal to product of electricity, product of current and resistance.
When the temperature and other physical condition is remaining constant, the current flowing between the 2 points of a conductor is proportional to the potential difference. That we know, right? So this has been stated. Huh?
The product of current and resistance are directly proportional to electricity.
That is the mathematical form. And Ohm's law is telling that a current is proportional to the potential difference when the temperature and other physical conditions are same, are constant. Now if I remove this proportionality, then V is equals to IR, we are getting it. Actually from Ohm's law we are getting this equation. Ohm's law is telling about this equation. And after that we are deriving it. Acha, we know also like resistance and conductance. What is resistance? That is rho, right? So resistance of a conductor, it is equals to directly proportional to the length of the conductor and inversely to the area of cross section of the conductor, where rho is the resistivity, or we can say it is the resistance, specific resistance of the conductor. Now, what is the relation between conductance and resistance? Conductance is inversely proportional to the resistance. So, whenever resistance decreases, conductance it increases. So, is it clear now?
Yes, sir.
Okay. Now I am making one. I maybe two images. Let's see. Okay, this is the first part.
Yes, sir, taken.